In this video, we're going to talk about solving compound inequalities. So go ahead and pause and copy down your title, standards, and your I can statements. And then also keep in mind that when we talk about compound, that just means that we have two inequalities that are going to be graphed on the same number line. Okay? So here we go with the first example. Notice that you've got two inequality symbols. You've got one here and you've got one here. Okay, so remember that those are going to be kind of like your boundaries. So notice that you've got the z minus 2 in the middle. What that means is you have to find the set of numbers, okay, that satisfies this inequality by solving it. So to do that, you just split it apart. So on the left, you have 7 is less than z plus 2, and then on the right you have z plus 2 is less than or equal to 11. So z plus 2 is less than or equal to 11. And then you solve those just like you normally would. Okay? So for the red side, you're going to subtract 2, and you're going to have 5 is less than z. And then on the right side, you're going to do the exact same thing. So you're going to subtract 2, and you're going to have z is less than or equal to 9. Okay? And then when you go to solve or to graph that, you just put down a number line. Okay? And you're going to have 5 as your lower boundary, 9 is your upper boundary. Okay, you have an open dot at 5 for the lower boundary. You have a closed dot at 9 for the upper one. Okay, now you need numbers that are in between. So you just connect the dots. Well, how do I know what numbers I need? Well, okay, this is an and statement. Okay, so that means that you have to put it back together in the end. So notice that you've got your lower boundary at 5, and then you've got the less than z. Okay, that's this one here. And then you've got over here, you've got the z is less than or equal to 9. So you have to make sure that you put it back together, okay? Because the and statement means that your numbers are going to be both greater than 5 but less than 9 at the same time. Alright, so let's do another one. Don't worry about that slide. Okay, so let's do another one. Do this one on your own, so go ahead and pause. Okay, so when you split, you have your negative 3 is less than x minus 2. And then on the other side, you're going to have your x minus 2 is less than 5. So then when you go to solve that, you're going to add 2. You're going to come over here and add 2 as well. Alright, so notice that your process is going to be the same. So you have negative 3 plus 2 is negative 1 is less than x. And then over on the green side, you are going to have x is less than 7. Okay, so now when you go to graph that, okay, your lower boundary is negative 1, your upper boundary is 7. They are both open dots, okay, and notice that x is in the middle, all right, your less than comes down, and then this one also comes down, and that's how you put it back together and then connect your dots. Alright, so that's how you solve an and statement. Now for an or statement. Okay, so notice that the word or is actually stated in the problem. Or statements are always stated. Okay, so there's nothing to split up, you just solve each one separately. So if you have your 4k minus 7 is less than or equal to 25, on both sides of that equal sign, you are going to add 7 to both sides. So that's going to give you 4k is less than or equal to 32. divide by your 4, and so you've got k is less than or equal to 8. Now, go to the next one. So you are going to subtract your 12. That leaves you with negative 9k is greater than or equal to 18. You're going to divide by your negative 9. That's going to leave you with k is less than or equal to negative 2. Don't forget to flip that symbol because you divided by a negative. All right? So now what you do is put your lower boundary on the number line. 0 will be somewhere in there. 8 will be up here. So we'll call that about 6. Okay? So now you have a closed dot at 8, which is right there. And you need numbers that are less than 8. So you know that this one is going to go in this direction. Okay? Now move to the negative 2. You also have a closed dot at negative 2, and then you need numbers that are less than or equal to negative 2. So that's also going to go in this direction. So this is what we call a union because the graph goes in the same direction and overlaps the other boundary. Okay? All right, so let's do one more. So go ahead and pause and give this one a try. Okay, so hopefully you had your minus 5 and your minus 5. So this was negative 2x is less than or equal to 10. Divide by that negative 2, and you have x is greater than or equal to negative 5. Moving on to the 5x plus 15, you're going to subtract your 15. That's 5x is greater than 5, and divide by that 5, and so x is going to be greater than 1. Okay? So then when you put it on a number line, your lower boundary goes first. Okay, and then so you have a closed dot at negative 5. And I need numbers that are greater than negative 5, so I know that I'm going to go this way. Okay, now I have an open dot at 1, and I need numbers that are greater than 1, so that's also going to go in that direction. So you start with your lower boundary, and you just draw the line through like that. Okay? Now, one more thing I wanted to point out is sometimes, okay, now the graph of your and statements are always going to go together, and they can be any combination of open or closed dots, okay? They can both be open, one of them can be open and one of them can be closed, or they can both be closed, okay? So any combination of open and closed dots for an and, okay? Now, or statements are a little different because, as you saw, we did a union where the graph is going to overlap its boundary in some way, shape, or form, okay? Again, any combination of open versus closed dots. But or statements will also go in opposite directions. And I wanted to point that out to you as well because you'll see that today on your assignment. All right, so make sure you bring your questions to class, and I will see you tomorrow.